Today, our next to last section. We only have one more section to go after today. Very close to the end. Section 6.2, inverse functions. F of x and g of x are called inverse functions if two things have to happen. F composed with g has to be x, and 2, g composed with f has to be x. So the other day we talked about composition, and one thing we noticed is when we do composition and we switch order, we don't usually get the same answer. But here we're going to say, to be inverses, we have to be able to switch order, and we have to get the exact same answer. It has to be x. All right, so let me give you an example. F of x is the function 2x minus 3. Anybody got a guess? What's the opposite of 2x minus 3? 2x plus 3. That's a good guess. It's wrong, but it's a good guess. Are those inverses, is my question. Well, I guess it wasn't fair because I didn't tell you what the question was first. I just told you to guess. So, are those inverses? It's a loaded question. All right, well, to see if they were inverses, I would do FOG. What do I get when I do FOG? Well, what does that mean? That means start with g. G is 2x plus 3. And I'm going to take that and I'm going to plug it in right there. So I'm going to have 2 times 2x plus 3 minus 3. I simplify that. That's 4x plus 6 minus 3. That's 4x minus 3. So are those inverses? The answer is no. Why not? To be inverses, what was I supposed to get? I was supposed to just get x. Did I get just x? No, I got 2x plus 3. Or 4x minus 3. So the answer would be no, those are not inverses. Well, let's try again. F of x equals 2x minus 3. Anybody got a different guess as to what the inverse might be?
Negative 2x plus 3.
Negative 2x plus 3. Another good guess. Unfortunately, also wrong. FOG would be, I take this, I plug it in there, so that's 2 times negative 2x plus 3 minus 3. That's going to be negative 4x plus 6 minus 3. That's negative 4x plus 3. Still didn't get x. Oops, this should have been a plus back up here. So, no, that one's not right either. Alright, so let me give you a hint. The plus 3 is good. Because what's the opposite of a minus 3? The opposite of a minus 3 is a plus 3. What's the opposite of a multiply by 2? Divide by 2. So we don't want to, if we're multiplying by a 2 here, we don't want to multiply by another 2 there. We want to divide by a 2. So let's try. G of x is x plus 3 all divided by 2. Are those inverses? How would you tell? Plug it in. All right, we have to do FOG. FOG would mean take this and plug it in there. So I would have 2 times x plus 3 over 2 minus 3. The 2's reduce. 2 divided by 2 is 1. And then x plus 3 minus 3. The 3 is also reduced. We're left with x. So are they inverses? The right answer is maybe. Because to be inverses, 2 things have to happen. FOG has to be x, and we need to be able to switch the order. And like I say, we saw the other day that quite often when we did FOG and then we did GOF, we got different answers when you switch order. All right, so we're going to try the other one. We got to do GOF of x. So GOF would mean we start with f this time, and we stick it in right there for that x. That's going to be 2x minus 3 plus 3, all divided by 2. When you simplify that, what do you get? You just get x, because negative 3 plus 3, those add up to 0. And then you have 2x divided by 2. 2 divided by 2 is 1. So that's x. So are those inverses? Yes, there's the right answer. Questions on that? All right, what I want to do now is I'm going to take these two functions. F of x is 2x minus 3, and g of x is x plus 3 over 2, and I'm going to build some tables. For f of x, give me a few of your favorite numbers in the whole wide world. What are some favorite numbers that you like? Negative 2, negative 1, 0, 1, and 2. All right, I'm going to go ahead and plug those numbers in. Starting at the bottom, if I plug in 2, I get 4 minus 3, that's 1. Plug in 1, I get negative 1. Plug in 0, I get negative 3. Plug in negative 1, I get negative 5. And plug in negative 2, I get negative 7. If you don't believe me, just try it. I did that quickly. I'm going to come over here for G, and I'm going to build a table. And I'm going to pick my favorite numbers for x this time. This time I'm going to pick the x numbers. I'm going to pick negative 7, negative 5, negative 3, negative 1, and 1. Where did I come up with those numbers? Were they special? Those are the y values that I got before, weren't they? All right, so let's plug in 1. If I plug in 1, what's 1 plus 3? 1 plus 3 is 4, and then 4 divided by 2 is 2. I plug in negative 1. Negative 1 plus 3 is 2. 2 divided by 2 is 1. Plug in negative 3. Negative 3 plus 3 is 0. 0 divided by 2 is 0. Well, without doing any work, what am I going to get when I plug in negative 5? And how about when I plug in negative 7? Negative 2. So, what can you tell me about inverses? What do inverses do? Well, what happened? The x's here became the y's over there, and the y's over here became the x's over there. Inverses interchange x and y. That's what they do. All right, so a question you might have had is, how did I come up with that answer? How did I know if f of x was 2x minus 3 that g of x should have been that answer? Well, here's what you do. I'm going to start with f of x equals 2x minus 3. And then writing the symbol f of x gets a little bit cumbersome. So I'm going to write the symbol y. What does the inverse do? Or did I just write that the inverse does? It interchanges x and y. So I'm going to take this equation and I'm just going to change x's and y's. So I'm going to write x equals 2y minus 3. I'm going to take this equation and I'm going to get the y all by itself. And when I do that, I will have the formula for the inverse. So how would you get y all by itself on that equation? Add 3, so x plus 3 equals 2y. Divide by 2. Y is x plus 3 over 2. So the symbol we use for inverse looks like this. We would write, instead of g of x, we typically write that symbol. That symbol's a little bit confusing because it looks an awful lot like an exponent, but it isn't. That's just a symbol that we use for function inverse. So we would say the inverse of 2x minus 3 is the function x plus 3 over 2. Questions on that? All right, let's say I gave you the function f of x is 1/3 x plus 5. And the directions might be find its inverse. Well, here's what you're going to do. You're going to write y equals 1/3 x plus 5. And really the only reason we do that is because it's easier to write the symbol y than it is to write the symbol f of x. Then what do? We switch them. That's right. Wherever there's an x, we write a y. Wherever there's a y, we write an x. X equals 1/3 y plus 5. And then we need to take that equation and get the y all by itself. To get the y all by itself, subtract 5. X minus 5 is 1/3 y. And then finally, divide by 1/3. That would be okay, but I don't like dividing by fractions. I'd rather multiply the reciprocal, multiply by 3. I'd rather do that. It's cleaner. So I multiply by 3. I have 3 times x minus 5 equals y. And just, does it look like it's reasonable? I mean, here we're dividing by 3 and adding 5. Here we're subtracting 5 and multiplying by 3. Do those seem like opposites? Yeah, they do. All right, so our answer would be f inverse is 3 times x minus 5. Of course, you could distribute and write it as 3x minus 15, but then it doesn't quite look as obvious that they should be inverses. But either answer would be fine. Now, unfortunately, not all functions have inverses. Let me give you an example. F of x equals x squared, and g of x is the square root of x. It's very, very, very tempting to say those functions are inverses. And it's very, very tempting to say those functions are inverses because we say it all the time that squares and square roots cancel each other out. But that's only partially true. And we talked about this a little bit a few minutes ago looking at one of the homework questions. Here's the problem. If I do GOF of x, I would take the x squared and plug it into that square root. And I would get that. And again, it's very, very, very tempting to say, well, squares and square roots cancel each other out, so that's just x. But again, that's not true, because it doesn't work for negative numbers. If I were to take x equals -2 and plug it in, I would have the square root of 4, which unfortunately is 2. So unfortunately, when I take a negative number and I square it, it makes it positive, and then when I do square root, I get positive. So what this actually turns out to be is absolute value of x. You can check it. This takes negative numbers and makes them positive. If I started with a positive number already, I'd be okay. If I started with x equals 3, I would have 3 squared square root. That would be square root of 9, which is 3. So it takes positive numbers and leaves them alone. It takes negative numbers and turns them into positive numbers. That's absolute value. The problem with this is really this x squared function. What's x squared look like if I were to graph it? What's the graph of y equals x squared? Begins with a P. It's a parabola. Looks like this. And I'm going to give you some points on this graph. This is 1, 1. This is 2, 4. This is -1, 1. And this is -2, 4. So imagine, if you will, if I took these points and I put them in a table. 2, 4, 1, 1, -1, 1, -2, 4. And I told you, write down the table for the inverse. What does the inverse do again to the x's and the y's? It interchanges them. So the table for the inverse would look like this. 4, 2, 1, 1, 1, -1, 4, -2. And there's something wrong with that table. Well, it's not that I did something wrong, but something not good with that table. What's not good? I have x values that repeat, don't I? X equals 4 repeats. X equals 1 repeats. So what's wrong with that? Well, what does it mean to be a function? To be a function means the x values can never repeat. Here we have x values repeating. So this thing that I just wrote, this is not a function. And that's why this thing does not have an inverse. So why did this happen? Why did it happen that when I switched the x's and the y's over here, this thing ended up with x's that repeated and turned out it wasn't a function? Well, why did the x's repeat here? Why did the 4's repeat here? Because the y's repeated back here, didn't they? And the 1's also repeated back here. So what has to happen? If I start with a picture and I want to talk about its inverse, what has to happen is none of the y values on the original thing can repeat. What's going to happen when I flip them and do the table thing? I'm going to have multiple x values. And there's a name for that. And it's called one-to-one. I ran out of paper here. A function is called 1-to-1 if no y value repeats. Remember, to be a function right away means that no x value repeats. So here we're adding more. We're saying not only can we have no x values repeat, We can also not have any y values repeat. And the fact is that only functions that are one-to-one have inverses. All right, so how do you tell? Well, you draw yourself a picture. There's two different functions. I'll call this one f of x, and I'll call this one g of x. One of those functions is one-to-one, and one of them is not. How do you tell? What's that? Did you say vertical line test? Vertical line test tells me if it's a function. So you're right, you switched your mind. If I draw any vertical line, it would hit only once. That tells me it's a function. To tell if it's one-to-one, we do the horizontal line test. So this first function g of x, if I were to draw any horizontal line anywhere, how many times would it hit that graph? Just once. So this one is one-to-one. However, this function g of x, I can draw a horizontal line, maybe right there, for example, and how many times does that one cross? Twice, which means we have a y number repeating. So this one is not one-to-one, which would mean this one does not have an inverse. This one, on the other hand, this f of x is one-to-one, because no matter where I draw a horizontal line, it would only cross once, and it would have an inverse. I'm going to give you a couple points on this graph. This right here, this looks like it's -2, 0. This looks like it's 0, 1. This one is maybe 3, 5. And this one is -4, -3. So if this is a function, which is one-to-one, and we already decided it is one-to-one, it should have an inverse. I want to draw a picture of that inverse. What would I do? What does the inverse do? What does the inverse do to x's and y's? Switches them. So if my original function has 0, 1, what's the inverse going to have? 1, 0. And if my original function has 3, 5, my inverse will have 5, 3. And I can keep going in this way. Instead of -2, 0, I'm going to have 0, -2. And finally, instead of -4, -3, I'm going to have -3, -4. So even though I don't know what the equation of the original picture was, and even though I can't find a formula for the inverse, I can say the picture has to look something like that. Inverses simply switch all the x values with all the y values. Questions on that? All right, now my last question for today. Who cares? Why do we care about inverses? There's a very famous formula. Anybody know what that very famous formula is for? It's temperature. So what's C and what's F? F is the Fahrenheit temperature and C is the Celsius temperature. Now, let's say you were taking a trip to Europe and you woke up in the morning and it said the temperature today is going to be 20 degrees. In Europe, what does that mean? Well, it's in what system do they use? Fahrenheit or Celsius? Celsius. We're about the only country in the world that uses Fahrenheit. So if you're traveling in Europe, they're saying it's going to be 20 degrees out. If it's 20 degrees, are you going to wear shorts and a t-shirt? Or are you going to wear jeans and a sweater? Jeans and a coat. And how would you decide? 50-50 chance. Step outside your hotel, see what it feels like, and then go back to your room and get dressed, right? Or your other option would be
do the math on the bar napkin from last night.
Do the math on the bar napkin from last night. That's right. And the math would be you plug 20 in for the Celsius temperature. And then you have to take this equation and you have to get F all by itself. So how would you take this equation and get F all by itself? You can't add 32. Because the 32 is trapped inside these parentheses. I got to take away the 5/9 first. How do I take away the 5/9? Multiply by its reciprocal, multiply both sides by 9/5. Let's see, 20 over 5, that's 4. 9 times 4 is 36. So 36 equals F minus 32. And then add the 32. F is 68. So the Fahrenheit temperature would be 68 degrees. So, shorts and a t-shirt or jeans and a sweater? Shorts and a sweater, maybe? That would look funny. But what might be more useful is, instead of having the formula written this way, it might be more useful to find its inverse. And what would I mean by find its inverse? What I would mean is, for us, it would probably be much more helpful if we had that F all by itself from the beginning, and then all we would have to do is plug in the numbers and it would be easier. So the inverse would be, I pretty much do what I just did. I multiply both sides by 9/5. So I'm going to have 9/5 C is F minus 32, and then add the 32. So F is 9/5 C plus 32. And now if I wake up in the morning and they tell me it's going to be 15 degrees, all I got to do is take the 15 and plug it in. And it's much easier for me to figure it out. So that's why we use inverses. Quite commonly, we have a function in one form, but it's more useful for it to have us in the other form. This happens a lot in chemistry and physics. Quite often you're converting one function from one form to the other. And quite often it's the inverse that you need. And that's what you would do. So if C is 15 now, F would be 9/5 times 15 plus 32. I don't have to do any algebra. All I got to do is work it out. I reduce, that's 3. 9 times 3 is 27. 27 plus 32 is 59. Questions on that?